Reed, ready for game night this weekend?
Totally. But what are we going to play?
We should use Board Game Buddy to help us decide.
Board game what?
Board Game Buddy. It's an app that lets you discover new board games and catalog your favorites all in one place.
Far out. Game night's going to be lit.
Board Game Buddy is a service-oriented application built with the board game lover in mind. It was created by a powerhouse team of two front-end developers, Priscilla and Patrick, and four back-end developers, Lane, Reed, Noel, and Connor. We came together to build this out of a mutual love of board games and a desire to see board games top charts, recommendations, and personal libraries in one application. The front end of our application is built in JavaScript and React to deliver responsive pages to our users. The front end is deployed using the Vercel platform. Our back end is broken down into two services, the board game service and the user service. The board game service is built on Ruby on Rails, deployed on Heroku, and its PostgreSQL database is hosted on AWS RDS since the size surpassed the free tier on Heroku, and we wanted to gain exposure with database platforms that can scale. The user service is built on Python and the Django framework, and it, along with its PostgreSQL database, are hosted on Heroku.
Hey guys, this is Patrick. I'm going to play a quick demo of the app while going over the front-end tech stack used. We wanted to go with something familiar to build the backbone of the app off of, so we ended up going with React JavaScript for our framework, just basic CSS for styling, some Redux for global state management. Even though that might be a little overkill for this application, we used the Redux for saving and unsaving games in this case. We deployed the app with Vercel and used Cypress for end-to-end testing. Now you can see in this little run through, I'm kind of checking out the details of a couple games, then routing towards this all games section. You can see there's 7,508 pages, and at 20 games per page, that equates to over 150,000 games. Searching by title, I'm going to look up Warcraft. You have all of these awesome World of Warcraft themed games. Now I'm going to search for the best games ever made of all time, High School Musical, and I have to save those to my saved games section. So I'm going to go ahead and do that and double check that they do indeed save to that section. There they are. Some of the challenges we faced on the front end was working with such a large data set. I think the way we overcame this was just keeping lines of communication open between Priscilla and I. Particularly if we had any blockers, we helped each other get unstuck. And not originally having all of the data present, there was a bit of upfront work for the backend to do before we could have that data. We used a JSON contract to overcome this, agreeing upon the shape of the data together. And that led us to this awesome end result.
Board Game Buddy's backend is a system of microservices, each with their own database. For our user service, we use Python and Django so that we could utilize the built-in packages for API consumption and caching, all while getting experience in a new language and framework. Coming from our background in Ruby on Rails, transitioning to Python on the Django framework was an exciting challenge, and we realized that the foundation we built developing CRUD applications in one object-oriented language made the process of learning another object-oriented language and developing an application within a new framework an approachable task. On the other hand, facing the comparatively huge task of cross-referencing more than 150,000 board game records between a publicly accessible CSV file and a single entry API endpoint available to us, we made the decision to build our board game service in Rails because of our familiarity with the rake task automations needed to generate our new database of board games. Because of the large number of entries, we decided to host the database using AWS, EC2, and RDS, while keeping the deployment on Heroku.
Process of building this application, we discovered that the third-party API we were using didn't expose all the endpoints we needed for our functionality, and there weren't other APIs that provided the data we were looking for. When we found this out, we had to figure out the best way to get all board game data into a filterable database. Our brainstorming session led us to the decision to build our own database that consumed the CSV of all 150,000 board games and cross-checked each board game in the database from the endpoints that were available to us. To do this, we wrote rake tasks that read the CSV, consumed the API, and cross-checked the data from each. We were able to leave our rake tasks running in the background, and they ended up taking about 12 hours to finish populating our database. In future iterations of this application, we would like to implement AI-generated suggestions based on existing user favorites, image uploading and storing, ratings that'll update the overall rating in the database for that board game, background workers to update our board game database during off hours, and authentication with refined user functionality so that users can make, edit, or delete their profiles.